Hello everyone. So today we are going to cover longest common subsequence. So here we are given two strings um, and we need to return the length of the longest common subsequence. This is Leet code problem 1143. If there is no common subsequence, then we need to return 0. Now what is a subsequence? Subsequence is the characters in a particular order in a string. So for example, in the string A, B, C, D, E, if you look at the character A, C, E, that's a subsequence, right? The A, C, E is a subsequence in A, B, C, D, E, right? So you are given two strings and you need to find the common subsequence between those two strings. And you need to find that the common subsequence which is also the longest. So now, a subsequence of a string is a new string generated from the original string with some characters deleted without changing the relative order of the remaining characters. So in this string A, B, C, D, E, A, C, E is the subsequence where we have deleted character B and D. A common subsequence of two strings is a subsequence that is common to both the strings, right? That is called a common subsequence. So here we are given an example A, B, C, D, E, and we are given A, C, E. So here the common subsequence is A, C, E, A, only A. So those are the subsequences, common subsequences. But we need to return the length of the longest common subsequence. Now the longest common subsequence is ACE between these two strings. And therefore we need to return the length of that longest common subsequence, which is 3. Let's look at the second example. ABC, ABC. Here the common subsequence and which is also the longest is ABC and its length is 3. Another example ABCDEF. Here we don't have any common subsequence and therefore we're going to return 0 because there is no common subsequence. Therefore there is no longest common subsequence. So let's look at the example and let's see how we can solve it. Okay. So here we are given a character A, B, C, D, E, and F, right? And here we are given the characters A, B, C, not A, B, C. Let's take something else. Let's take A. Let's take A, C, E, and F. Okay. So this is your string 1. And this is your string 2. Now here the common subsequence is this A, C, E, and F, right? And the length of that subsequence is 4, right? So the answer is 4. Now how we can solve it, okay? So let's think of the approach how we can solve this problem. So we are given two string A, B, C, D, E, F, and then A, C, E, F, okay? Let's assume we have a pointer here because, or maybe it's not there, just let's do a brute force way, okay? So what we can do here is we can compare these two characters, right? Now both of the characters are same. So we can add this one character is a common subsequence. Then we're going to increment our pointer. So our pointer goes to B and here it goes to C. Now here B and C, they don't match. Okay. So now since the characters are not matching, we have two options here. Okay. I can either ignore this B and move on to the next character. That is option number 1. Okay. So my option number 1, when characters not match, right? When they don't match, my option number 1 is I delete or ignore a character in string 1, right? So delete or ignore the character in string 1. That's my option number 1. Option number 2 is, so we have this string. My pointer is here. My pointer is here. Option number 2 is I ignore a character in this string and I move this pointer forward, right? So that is my option number 2. Option 2 is delete or ignore character in string 2, right? So let's see what I'm doing. Let's see, I'm ignoring a character in string 1. Okay. So if I do that, okay, then my pointer will move here to C, and here uh, and here the pointer will stay here. Now here both the characters are matching C and C. So I'm going to increment both the pointers. Okay. So now my pointer is D and here it's E. Now when the character match, I need to add 1 to the count. So I'm going to do +1. Now here they are not matching. So what I'm going to do is I'm going to ignore this character and I'm going to move forward this pointer. Now both the characters are matching. So I'm going to do +1. And I'm going to increment both the pointers. Both are matching. So +1. So that is 4. So that is the length of longest common subsequence, right? So I have 3 options. I have 2 options if the characters are not matching, right? But from those 2 options, I need to choose the option that gives me the longest common subsequence. So what I'm going to do is I'm going to take a job of a lazy manager, okay? I'm not going to do my work. I'm going to do work for only the first character that I'm looking at. So I have this string abcd, and here I have ACE. We are going to take the same example that is given in the Leet code. So now we are going to take a recursive approach of a lazy manager. So we are going to start from the last character. Now here both the characters are not matching. I'm a lazy manager, so I'll do my job. I'll call 2 of my subordinate, okay? First subordinate, what I'm going to give him, I'm going to delete this character and I'm going to move this pointer forward and give that to my first subordinate. So my first subordinate will have this A, B, C, D and E. D, and E. So I'm going to ignore this last character or delete the last character, and I'm going to give this. Oh, sorry, these are matching. Just give me one sec, okay? I just changed the order of the characters. So now they are matching, right? The character E are matching, right? So here the characters are matching. So I'm going to decrement both the pointers, and I'm going to say, okay, I have one character. I found out that one character in that longest common subsequence. So I'm going to add one, whatever answer I get from my subordinate. And I'm going to give the subordinate who is working under me, I'm going to give him this string. And now this is pointing to D and this is pointing to C. Now my subordinate is also going to delegate his work. He's going to handle just one character, and then he'll going to give rest of the work to his subordinate. So now he sees that, okay, both the characters are not matching. So I need to hire two subordinate. To this subordinate, I'm going to ignore the character in string 1 and give him that. So I'm going to give him this. And to this subordinate, I'm going to ignore the character in string 2 and I'm going to give him that. Right? And what he's going to do is he's going to ask both of them, you guys go and find out the longest common subsequence for this string, in this string. And whatever, and you go and find out the longest common subsequence in this string. And whatever the result that he will get, he'll take the max of that. Whatever the result his subordinate returns. So now here both the characters are matching. So he knows that, okay, I found one more character in that longest common subsequence. And I'm going to delegate work to my subordinate by decrementing both the characters. So now, both the pointers. So now my string 1 is pointing to B and this is pointing to A. And here the D and A are not matching. So he has two options. Either to remove the character from string 1 or remove the character from string 2. So in the first option, he will remove the character from string 1 and he'll give this to his subordinate. And in the second, he'll remove the character from string 2. So now this has become less than 0. Now whenever it becomes less than 0, we have no more string left here. So there is no more common subsequence that we can find. So this is our base case and we need to return 0 from here. And here, so here this also has two options that he's gonna give. So first we will remove a character from string 1. So this will point to A and this will point to A. Both the characters are matching. So he knows that, okay, I found one more character in this common subsequence. And he's going to decrement it. So now here, the pointer goes less than 0. We have no more string left in string 1. and there are no characters left in string 2 as well, so this is going to return 0. So 1 plus 0 is 0 and 1 plus 0 is 1. So this subordinate is going to return 1. Now let's see what this one returns. This one delete the character from string 2. So it's going to point here. Now no more string left here. So there is no way we can find a common subsequence. We need to have the character in string 2 or string 1. So this is going to return 0. Now 0 and 1. So this subordinate is going to take the max of whatever answer that has been given to him, because he needs to find the longest common subsequence. So he is going to return 1, and that 1 will be added here, so the answer will be 2. Now this subordinate is going to take the max of 2 and whatever is written here. I think here the longest common subsequence between this and this is 1 character, so this is going to return 1. The max of 2 and 1 is 2, so 1 plus 2 is equal to 3, and therefore the answer 3 will be written, and that is our final answer. So this is how we're gonna do. So we are going to do write our recursive function. Our recursive function will take word 1, the length of that word, which is n, word 2, the length of that word, which is m. Now what is our base case? If we don't have any characters left in word 1 or word 2, that means we cannot find the common subsequence. Therefore, we are going to return 0. So base case is if n is less than 0 or n is less than 0, right? In that case, we are going to return 0. I forgot to discuss about the time complexity. So here, if you look at the recursive tree, we have 2 branches. I mean, if there is a match, then we have only 1 branch, but if there is not a match, then we have a 2 branch. So the branching factor is 2, and the height of the tree is n plus m, right? That is the max height of the tree. So our time complexity is O of 2 raised to n plus n. And our space complexity would be the call stack, the recursive call stack, which would be n plus m, which is nothing but the height of the tree, right? Because we are either decrementing m or n, so the height of the tree will be n plus m. So now we have 2 cases, right? So if word 1 dot character at n equal to word 2 dot character at m. So if both the characters are matching, then what we are going to do? We are going to return the characters are matching. So we already found a one character in our common subsequence, the longest subsequence. We are going to make a recursive call to our subordinate by decrementing both n and m. So I'm going to make a recursive call and I'm going to decrement n, and I'm also going to decrement m. So that is our case 1. Our else cases, the characters are not matching, right? So if the characters are not matching, then we have two options. We need to take a max of deleting a character from string 1 and then deleting a character from string 2. So we are going to return max. If I delete a character from word 1, I need to decrement n. And if I delete a character from word 2, I need to decrement m, right? So that is our else case. And we are done. So this is a recursive approach. It's a top-down approach. We started with n and m until n and m became 0. And as you can see, here the time complexity is exponential. So now let's write the code for the recursion that we discussed. So first of all, we're gonna write our base case. We need recursive function where we need to pass m and n. So our n is text1 dot length minus 1, and our m is text2 dot length minus 1. And we are going to call our helper function, which is our recursive function, and we're going to pass text1 and text2 and m. And here our recursive function will return the length of the longest common subsequence, so it's going to return integer. I need to rename this function as a helper function. And now here we are going to write our base case. If n is less than 0 or m is less than 0, if any one of the string is empty or done, we're going to return 0 because there is no way we can find the longest common subsequence. And then if text1 dot character at n is equal to text2 dot character at m, In this case, the characters are matching, so we're gonna add 1 to our longest common subsequence, and we're gonna make a recursive call by decrementing n and m. Our else cases where the characters aren't matching, in which case we're going to delete 1 character from string 1 and 1 character from string 2. And we're going to return the max. I need to call helper function here, which is my recursive function. So here I'm going to ignore the character in string 1. Again, call with ignoring a character from string 2. And that's it. That's our code. 4 lines of code. So this solution is going to time out because our time complexity is exponential. It's not an array. It's a string, so length time limit exceeded. So we knew that because since our solution is exponential, it is going to exceed the time limit. So now let's look at how we can improve this solution. So if you look at this code, right, there are overlapping subproblems. So let's see. So if you look here, this is pointing to A and this one is pointing to T and C. Let's see. Okay, let me take an example to show that there are overlapping subproblems here. This example isn't showing that. Okay, let me take another example. So if I have this PCE and right, if I have this example, and we start from here, they are not matching. So we're gonna have a two subproblem. In one subproblem, this is gonna be like this, and in another subproblem, it's going to be like this. Now here, again it's not matching. So again two subproblem. And this subproblem, it is going to be like this. And in this subproblem, we are ignoring character from string 2, so it's going to be like this. And here, we are ignoring a character from string 1. So it's going to be like this. So if you look at this two problem, so those are overlapping subproblem. Whatever operations we do here onwards, right, we're going to repeat those operations. So we have an overlapping subproblem, and we also have an optimal substructure. Optimal substructure is if if this is going to be returning me the longest common subsequence between these two strings and these two substrings, there's no other way you can find the longest common subsequence. I mean, whatever is written from here and whatever is written, the final answer written from here, this would be the longest common subsequence for string G, H, I, F, B, C, and I, B, Z, right? It is an optimal substructure because there is no other way. Because if there is another way to find the longest common subsequence, then the answer we get here will not be correct. So whatever answer we are getting from here is the longest common subsequence. And there is no other better approach than that. I mean, there is no other answer than that. So what we can do is we can convert this to dp, and to convert it to dp, we need to remember what was our recursive function. Our recursive function had string 1, string 2. Okay. Now here in this function, what are the parameters which are changing whenever we make a recursive call? This two parameter. What is the type of that parameter? Integer. What are we returning from our recursive function? Integer. So for dp, we need 2D table. Why? Because we have two parameters which are changing. Since our return type is integer, we need a 2D int table. And what should be the size of the table? Whatever the different values the n and m will hold, right? So in this case, we will take the size of the table as n plus 1 and m plus 1. Why? Because if n becomes less than 0 or m becomes less than 0, there's no way in matrix we can show that minus 1. So we'll show it by 0. So we're going to create a 2D integer table of size n plus 1 and m plus 1. Okay. So for example, if we have this A, B, C, D, E and A, C, E, right? So here, so here we have created an integer table of n plus 1 and n plus 1 size. This is our index 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, right? Now we need to fill in the base case into our TP table. What was our base case? If n is less than 0 or m is less than 0, that means we don't have any character in the string and therefore the length of longest common subsequence is 0. So we need to fill in that case. So here less than 0 is nothing but 0 because we cannot have a negative index. So if this n is 0, then the longest common subsequence is 0, and if m is 0, then also it's 0. So that is our base case. Now when we are in this cell, we need to see whether this character and this character are matching. Yes, they are matching. So what will be the answer? 1 plus, we need to decrement both n and m. So the answer will be dp of I minus 1 j minus 1, which will be 1 plus the value of this cell, which is 0. So the answer here will be 1, right? The value of this cell will be 1, right? Then we go row by row, because if you look at our recursive functions, we were making recursive call to this, then we were making recursive call to n minus 1 and m, and another recursive call was n and m minus 1. So the values we need are from this cell, the cell above, the cell before, and the diagonal cell, this cell. So we only need values from these 3 cells. So what we can do is, we can go, we need value from this cell, we need value from this cell, and we need value from this cell. So what we can do is we can go row by row, because that is more cache friendly. In the cache, when you pull in one row, it will pull 10 other values. So that is more cache friendly instead of column by column. So we'll go row major order. So now we came this cell. This is A and this is E. Sorry, C. A and C characters are not matching. So what we're gonna do? We're gonna take max of 1 and 0. What is max of 1 and 0? 1. Now here A and E, the characters are not matching. So you're gonna take max of this and this, right? Max of this and this, because we are deleting character from string 1 and deleting character from string 2 and taking the max. So that is nothing but it is a max of dp of I minus 1 j dp of I j minus 1. So here also we're gonna have 1. Now B and A not matching. So max, which is 1, B and C not matching, max, which is 1, B and E not matching, max, which is 1, C and A not matching, max, we're gonna take max of both the cells, which is 1. C and C are matching. So what we're gonna do, we're gonna take this diagonal value and add 1 to it. So our answer will be 2. C and E not matching, so we're gonna take max of this, which is 2. D and A not matching, we're gonna take max, which is 1. D and C not matching, max, which is 2. D and E not matching, we're going to take max, which is 2. C and A not matching, we're going to take max, which is 1. C and C, of course the characters are matching, so we're going to take this value and add 2. Oh, this is E, I'm so sorry. This is E. So C and E are not matching, so we're going to take max, which is 2. E and E are matching, so we're going to take this diagonal value, add 1, so the answer is 3. And our answer will be in the last cell, which is this one. So that is our answer. So if we take the DP approach, our time complexities, if whatever the time we took to iterate this table, which is O of nm, and our space complexity is the same, the size of this table, right? So once you have a recursive code, writing a DP code is just a manual work. And let's do that here. Let me reset this. And let me write the DP code. Okay, so I'm going to take a 2D integer and is equal to text 1.length and text2.length, and I'm going to take 2D integer table whose size will be n plus 1, m plus 1, and then I'm going to iterate row by row. So I less than equal to n I plus plus for integer j is equal to 0, j less than equal to m, j plus plus. So what is our base case? If I is equal to 0, then dp of I, j is equal to 0. And if j is equal to 0, then dp of I, j is equal to 0. So that was our base case. Now if none of that is true, then we're gonna compare the character. If text 1 dot character at, I need to do I minus 1 because the string is 0 base index, and here we are the character. I mean, if you look here, A is character number 1, 2, 3, but when you do character at, it's 0 based, so we need to do I minus 1 is equal to text 2 dot character at j minus 1. If the characters are equal, then remember what we need to do. We need to add 1. dp of ij is equal to 1 plus, and we need to decrement both I and j. Remember the recursive function call that we were making here, decrementing n and m. Else, we need to take the max by deleting a character from string 1 and deleting the character from string 2, which would be dp of I minus 1j dp of I, right? So that is our dp, and our result will be in the last cell, which will be dp of n and m. And let's submit. And there you go, it's accepted. And now, since the time complexity is mn, there's no timeout and the solution is accepted. Thank you so much for watching the video.